That'd be helpful. Anything else you can remember? No? Anybody want to ask any questions about that? Was it reasonably comprehensible to you? Yeah. Ish. Good. All right. Yes, so what I'm going to do today, partly again because I've had problems even getting into a PowerPoint, I'll move on to multiple regression, and then what we'll do is we're going to print out, fingers crossed maybe I can access SPSS, but if not, we will all look through the addition notes where I put the printout for you, and we'll look at the various parts. So that's what the plan is. So what is multiple regression? All it is just an extension of what we did last week. Last week we just had 2 variables, but for multiple regression you can have several predictor variables. Does everybody remember the terminology predictor for the variables that you're using to predict the dependent variable, also known as criteria? People remember that bit of terminology from last week? So, multiple regression, you can have several predictor variables. And in a way, that's a bit more realistic, isn't it? I mean, you will come across many research articles in health or clinical or personality where you've actually got several predictor variables. It is more realistic that a researcher might want to measure several things rather than just one thing. And what this multiple regression analysis will do is it's going to indicate how the combined predictor variables altogether. So if you've got 3 predictor variables, it will tell you how all those 3 predictor variables combined together are related to the criterion. And it's called multiply. So rather than last week, we were just looking at sort of Pearson's R, single sort of between 2 variables. Now we're going to look at how the several predictor variables correlate with the dependent variable. And that's called multiply. And the other thing it's going to give us when we start looking at the printout, we're going to get an idea of which is the most important of those predictor variables. So that's going to be quite useful. So not only will we see how well they altogether simultaneously predict the criterion variable, we're also going to be able to see which of those variables is the most important in predicting. Okay, so that's the sort of essence of multiple regression. There's actually several different approaches, and there's quite a lot more sort of theory behind it that I'm not going to go into, because there's different ways in which you can put those predictor variables into the analysis. And there are some issues around, well, which method of multiple regression do I choose? What we're going to do in class, and what we'll do with James for your data for that too, and incidentally it's portfolio exercise next week, I'll put it up into week 8 for assessment. Yeah, I'll probably put it in both places. So just tidying that up, but that'll be ready for next week, and James's data will be ready for next week. But what we're going to do is use a method called enter, where you enter all the predictor variables in one go. That's what we're going to do. And that's also called simultaneous regression. But there are other ways that you can do it. You can say, well, look, I want predictor variable 1 first into the analysis, then I want to put in predictor variable 3, and then finally I want these SPSS analysis to put in predictor 2, say. And you get slightly different results coming out depending on how you put those predictor variables in. There's also something where you can put them in forwards, you can put the variables in going forwards, or you can say I want them to go in backwards. So there are different choices, and all I want is for you to be aware of that. You can get slightly different results. It can be a bit of an issue, well, what shall I do? But we're going to enter all the predictors in one go, and you're going to see the enter method of the analysis. Okay. So that's just a little bit of background. Let's sort of move into our example just to make it a bit more concrete for you. So just extending our example with Simpson and Everett. Remember we were interested in how you can predict reading. So we had letter naming and text reading, as you've all remembered. letter naming and text reading was what we used last week. But now, let's assume they took some other measurements of all the children in the reception. So they tested the child, for example, the child's rhyming ability. That's often a test used for phonological awareness, which is supposed to be quite a strong predictor of dyslexia, how phonologically aware you are. So rhyming ability, letter names we've already done, and sounding out letters, for example. So they, actor, their ability to sound out the different phonemes of the word, for example. So let's say they took those. So is everybody happy that we've now got 3 predictors? Yeah, not just one letter name. So we might be interested in saying, well, which of those measures might be the best predictor of prose reading in year 2? Let's try and get a handle on which of those measures would be the best predictor, which might be that the teacher could actually use that measure as a sort of single predictor. We're also going to see, well, do they all together predict text reading? So that's what the multiple regression is going to do. So criterion variable is text reading. So we're going to use the standard enter multiple regression, and actually the SPSS is just the same as it is for bivariate analysis. You should see on my additional notes that I've just got some quite basic SPSS instructions at the back. And really, the only difference between doing bivariate, which we did last week, is you just pull one predictor over, but when you're doing multiple, you pull several predictors over. So it's no different. You'll find it very easy, I know you will. But now that we've got several predictors, don't try and do a line of best fit, because we've got several predictors. We can't just fit one line. You can if you're looking at the variables individually, but when you're entering them into a multiple regression analysis, you're putting them all in one go, and so you can't really do a line of best fit. So don't need to do that. Okay, just like you've learned with the sort of analysis of variance, there are certain requirements that you're supposed to satisfy. Can anybody remember one requirement from when we did ANOVA? Parametric ANOVA. Normally distributed data, yes, well done. So the data should be reasonably normally distributed. Pardon? Not the same scores, do you mean homogeneity of variance? Yeah, yes, so that's okay, wasn't it? Yeah. Well, the variances for each condition should be roughly the same. And then what was that special requirement for within subjects designs? Sphericity, very good. So we had some requirements when we did ANOVA, but similarly there are some requirements when you do parametric multiple regression. So we'll just have a little look at those. I think you'll find that James will have had a look at these when you get the large data class. So I don't think he asks you to do this, but just we want reasonably normally distributed variables. We do, because we're doing multiple regression, we would expect that the predictor variables will have some sort of correlation, linear correlation with the criterion. So you could actually just check that by doing a quick bivariate regression or bivariate correlation for each of the predictor variables, rhyming, letter sounding out, letter naming and sounding out. You could just do a quick sort of correlation with the text reading in year 2 of each of those separately, just to check that there was some sort of reasonable scatter plot going up the diagonal. Okay. So you could do that, you know how to do that. So they should be at least linear related. But one of the things is, if you don't want the predictor variables themselves, letter naming, sounding out, and rhyming, you don't want them to be too strongly correlated. Because it might be, if they're very highly correlated, they're effectively measuring the same thing. And that's not good for the multiple regression model. So that's called collinearity. So how do you think we could have a look for collinearity to see whether the predictor variables were rather highly correlated? Well, you could ask SPSS for a table of correlations, and we're going to do that. Actually, multiple regression does have sophisticated procedures for checking collinearity and several other things that I'm not going into. But we could just have a look at our table of correlations and see if any of the predictors are correlated with each other around about 0.8 or so or higher. And if they are, we'll drop one of those variables. So, any questions on that? This idea of you don't want the predictors to be too strongly correlated. Does that make some sense to you? Because they might effectively be measuring the same thing. If you've got a correlation of 0.9 between one variable and another, arguably you could say, well, perhaps they're measuring the same thing. But in any case, it's not a good thing to put it into a multiple regression analysis. So we'll keep an eye out for that. The other thing, just in case any of you prefer using multiple regression next year in your project, you do need to make sure you have a reasonable number of participants for every variable that you put in. So you can't just think, right, well, I'll test 20 people and I'm going to measure them on 15 things, 15 variables, because you just wouldn't have enough participants for the multiple regression analysis. So a certain number of participants are needed. And in the past, they usually say, for every variable you put in to your analysis, you really need about 15 or so participants. Anyway, I'm just sort of giving you an awareness of this, but if anybody was going on to postgraduates, then they would need to know quite a bit more, and I can refer you to more advanced books if anybody's doing that. Or maybe even if you're doing the multiple regression for your project as well. How many of you managed to read the Dancing reading chapter? I think you'll find that quite useful on regression. Yeah. You might well find that quite useful. I'll go through other examples and other ways of looking at it. So I would recommend that. Okay, so in a minute we're going to try to do the SPSS on some data that I made up for the reading example. Just to give an overview, what are we going to look for? Well, we're going to look for some descriptives, correlations. We're going to ask SPSS to give us a correlation matrix, actually, so that every variable will be correlated with every other variable. And you get a little table. We're going to look for that multiple R value that I mentioned. We're going to come up with a multiple R. We're going to look at R squared. Anybody remember what R squared was? I mentioned that last week. We didn't recap on that. It's the amount of variability in the dependent variable that is explained by the predictor variable. So we're going to have a little look at that. We'll get an ANOVA table, which you saw just briefly at the end of last week. So we're going to get all the same components that I put up on the screen last week for the simple bivariate. It's going to be it's going to be the same. And we're going to get a table of coefficients as well, which again we had a quick look at that last week, and we'll be able to find our A and B values from that table of coefficients. Okay, so let me see if I can possibly get into SPSS, but I'm really not hopeful, but you never know. So good. This I can't do this in my office, so that's brilliant if we can get into SPSS. So at the back there, how many of you got your additional notes? Okay. I mean, not so many at the back, but because it may be that you won't be able to see the screen, in which case I would suggest you come forward a bit. But those of you who got your additional notes, you'll be able to see where my cursor is for the printouts, and you'll be able to follow it. But I would suggest that if you haven't got your additional notes, and we'll be looking at page around about 15 onwards in the additional notes, if you haven't got those, I would suggest that you move forward, because you'll benefit more from that. some variables in SPSS like you did, like you saw for the ANAVA. So we've got a variable, a column of data, which is letter naming. We had that last week. We've got a column of data for prose reading in year 2, a column of data for sounding out, the child sounding out, and a column of data for the child rhyming. So there we are. Here's child 5, whose score on prose reading is 26, whose score on rhyming is, so child 5's score on rhyming is 15. Can you see that at the back on your additional notes? Yeah. Okay. Here's child 12, could only read 7 letters. Prose reading in year 2 was 11. Sounding out, they could only do 6 words. And rhyming, they only got 5 correct. Okay? In reception years. So, which variable is this? Using our correct terminology, which variable is that one? Criterion. So that's what we're predicting in year 2, aren't we? What variable is that? It's a predictor. And here's another predictor, and there's another predictor. So we've got 3 predictor variables. Right, I'm not going to check whether the data are normally distributed. I've only got 16 data points. So you know that really that's not enough data, but there's a limit to how long I can spend making up data to illustrate the teaching points. So we're going to do this multiple regression. So we're going to go up to analyze, down to, where do you think I'll go down to? Regression, and then linear. Okay, so what do you think I'll take over to this box? Prose reading, yes? Criterion or dependent variable, and then we'll take all of them over. So last week we just took letter naming over, but now we're going to take sound and rhyme. The first thing I want to do is, let's get some descriptives because that will give me the correlations. Why do I want to look at the correlations? Anybody remember?
The collinearity.
Yes, very good. We're going to see if there's any collinearity between the predictor variables. In other words, do some of those predictor variables correlate too highly together? So I'm not going to, first of all, I'm just going to get that. Okay, so ignore the rest of it. You can see, those of you at the back, you should be able to see the table of correlations on page 17. It should be the same, I don't think I've altered the data yet. So table of correlations.
It's last week. It's last week's now.
Oh yeah, no, I put it up on Friday.
No, it says regression.
Ah, well, I don't know how you got hold of an old example.
Well, last week, regression analysis. Joe?
Okay, well you can see the screen anyway.
Joe?
Yeah, you need to go back out and print the additional notes that I put up on Friday. I don't know how you got alcohol. But have you printed out? Who's got letter and prose and... How many did you print out? Let's see what you've got.
Got it here. Was it last week?
Oh yeah. Yeah, you would have printed it out last week. But those are the ones after that. Some of you are looking at confidence intervals, which I'm going to do at 12 o'clock. Right. You should be looking at your multiple regression that you would have had last week. Yeah, week 6. You would have printed it out about 10 days ago. Yeah, you need your regression printouts from week. They were in week 6, so you should have printed them out last week. Now, how many of you got those? Good. Excellent. If not, as I say, you need to come down to the front. Okay, so can someone tell me what the correlation is between letter and sounding out? Letter naming and sounding out. What's the correlation? 0.822. Can you see that? Yeah. Okay. Can someone tell me what the correlation is between rhyming and sounding out? 0.627, a positive correlation. What's the correlation between letter naming and prose reading in year 2? 0.920. Yeah, good. Is it a significant correlation? So that's when you drop down to here, letter and prose. So this tells you the actual correlation coefficient. Here, this little box is telling you whether it's significant. So is letter and prose significant? Yeah, where my cursor is. Yeah, he is less than 0.001. Did you see my feedback? We looked at the feedback I gave you before. Hopefully it's helpful for you. The 0.001. Feedback on your portfolio. I put it in assessment. Okay? Yeah. There's quite a bit of feedback there that will be helpful for you. For your portfolio exercise 1 and 2, I've given you some generic feedback, but they were very common errors. Right. Now, do you think 2 of the predictors are quite rather highly correlated? Remember I mentioned 0.8, 0.9? What about letter and sound? Yeah, they are quite highly correlated. So what we're going to do, I think there is some collinearity there. We're going to drop the sound variable. We're not going to put it in the regression analysis. Okay? We're not going to bother with the sound because there's a high correlation between predictor letter naming and predictor sounding out. 0.822. So we're actually going to drop it. Okay, so I'm not going to do a regression. We're not going to pop it into the analysis. Is everybody happy with that? There's a high correlation between predictor letter naming and predictor sounding out. 0.822. Therefore, I consider that too high, and I'm not going to put the sounding out variable into the regression analysis. Okay? Right, now I'm going to go back and do the regression. So, analyze, down to regression, linear, and I'm going to take the sound variable out, okay, because it's too highly correlated. I could ask for confidence intervals. I'm going to lecture to you for those of you who want to come, so I'll talk to you about confidence intervals. Perhaps we'll leave it for now. But you can see that you can ask for confidence intervals. And we'll just press OK. And here we have our printout. Exactly the same as we showed you last week for the bivariate. So we just looked at the table of correlations. Here are the means and the standard deviations. You might want to put those in a table, but be very careful not to compare a mean with another mean, because they're different measurements, aren't they? So you can't, letter naming is measured in a different way to rhyming. So you can't say, oh, this mean is bigger than this mean. It doesn't make an awful lot of sense. So be careful there. But you can look at things like, is there any variability around that? What's the standard deviation like? So you can look at the check, and you can also look at the range as well. Are participants using, are they going across the whole range of the scale? So I think James asked you to get to the range. Okay, so we've done correlations, but now this is telling you what model you're using for regression. And can you see it says enter? Remember I talked about enter or simultaneous regression. So we know that we've ticked the right box. Actually, that's the default. And what happens is that all the variables are going to be simultaneously regressed onto the dependent variable. So remember, they enter all the variables in one go. So that's just reminding us what method we're using, and we're using the default enter, simultaneous regression. here, next box. You see that in your printouts? Yeah. Okay. Multiple R is 0.931, very high because I made up the data. So what that is telling us is that there's a high correlation between all two predictor variables and the criterion prose reading. So there's a high joint correlation there between the two predictors jointly together in how they are correlating with the dependent variable or criterion, which is prose reading. R squared, somebody tell me how much variance is unexplained. So how much, look at R squared and tell me how much variance is, approximately how much variance is unexplained by those two predictor variables. 16, isn't it? Approximately 16, 15. Look at the, usually we take the adjusted R. Can you see that it's about 85%? Okay, so 85% of the variability in prose reading in year 2 is explained by those two predictors jointly. That's a heck of a lot. In a real life, it wouldn't be that much. So only 15% of the variability in prose reading is unexplained by the regression model with these two predictors. Okay. Here's the ANAVA table telling us whether or not those two variables significantly predict prose reading. And do they? Those of you at front, do they? Yeah. P is less than 0.000. Can we have a go at writing, at chanting out the F value formally? F, open brackets, 2, comma, 13, very good. Yeah, I mentioned at the end of last week that the residual is like our error term. So 2, comma, 13, close brackets, equals 42.07, P is less than 0.001. Okay, so those two predictors together, they jointly and significantly predict the criterion prose reading at year 2. Okay, so is everybody happy so far? We've looked at multiple R, it's very high. We've looked at the explained variance. We've seen that the predictors significantly predict. And then finally, we come down to the table of coefficients, which is where you can find out, get an idea of which is the more important predictor. So, last week we only had one predictor, but now we've got 2. So which of those is the more important predictor? And what you do there is you look at the standardized coefficients. Why do you think we're looking at standardized? We're going to try and compare the predictors to see which one is more important in predicting prose reading. So why do you think we're using something called standardized B or beta values? Why are we doing that? What do you think the SPSS has done? Average. Not average, no, good guess, but what it's done is standardized the variables so that you can directly compare them. So rather than using the raw scores, letter naming and rhyming, which I told you were different measures, what happens to each of those variables is they get standardized. Do you remember Z scores vaguely? Yeah. So they get standardized so that you can actually compare them directly. Okay. So that's what we do. And just looking at those betas, which one is higher? Letter naming. Letter naming is higher standardized beta score than rhyming. So it looks like letter naming is a better predictor. Of the two variables, letter naming is the stronger predictor of prose reading in year 2. So this is the stage in the table of coefficients where you get an idea of the relative contribution of your several predictor variables. Okay? Can you tell me if it's a significant predictor? Yes. And look, because you've got a little t value there. So t equals 5.999, p is less than 0.001 for letter naming. So it is a significant predictor when the other variable is held constant. because that's what we're getting there. In that table of coefficients, what we're doing in the simultaneous regression is looking at the effect of one variable while holding any other predictor variables we've got constant. Taking them out of the sort of analysis, holding it constant, saying if we hold all the values of rhyming constant, does letter naming predict prose reading? And yes, it does. When you hold letter naming constant and take a look at rhyming, is it a significant predictor? No. Actually, rhyming isn't. So when you've accounted for any variability, shared variability due to letter naming, rhyming does not, on its own, predict the text reading at year 2. So here we're getting a bit of a handle on the two, which of those two variables are predicting. It looks like letter naming is carrying the most important predictive sort of role. Okay. And then here, in the other part, I know Dr. Walter's coming in a minute. Here, in the other bit, this is your value of A. Remember I showed you that last week? And these are your values of B, which you could use for what? Why might you be interested in A and B? For the regression equation. Yeah. So just like in bivariate regression, we had y equals bx plus A, in multiple regression, it's similar, but we've got several b values. And James Walsh may show you how to do the regression equation in a bit more detail. It is in my notes to you and on the PowerPoint. But if a child came along to reception and you had their scores on letter reading and on rhyming, you could bump those into the regression equation with the b values, with the a value, and you could work out their predicted prose reading at year 2. Just the same principles as last week, but now we've just got 2 predictors. Okay? Okay, so I'm going to log off now. What you're going to do, James is going to come in probably now in a minute, and he will log on and start talking to you about Lab 2, but he's going to take you through multiple regression again, and you know, it'll make more sense, you'll get more practice, and then you'll do it next week in SPSS. Okay, so 12 o'clock, how many of you want to